With dense attention, the query at position 500, 000 can score against the key at position 200, 000. The connection costs compute, but it exists. With a sliding window of 1,024 tokens on each side, position 500, 000 can see positions 498, 976 through 501, 024. Position 200, 000 is invisible. The model cannot link the error to its cause. It sees the traceback but not the function. It sees the symptom but not the mechanism. You could expand the window, but expanding the window brings the cost back toward quadratic. You could add more global tokens, but you're choosing which positions are global before you know what the query needs. The problem is fundamental. A fixed pattern decides what to attend to before the model knows what matters. The pattern is blind to content. It is a budget allocated before the question is asked. For agents running long-horizon work, where the critical connection could be anywhere, in a million-token history, it is a structural failure. The agent needs the ability to reach across the full context selectively, to attend to position 200, 000 when position 200, 000 matters, and to skip it when it doesn't. That requires the sparsity pattern to depend on what the model is currently processing. If this kind of first principles breakdown is useful to you, consider subscribing. We go this deep on every video, and the next section is where GLM5.2 solves the problem we just described. DeepSeek Sparse Attention solves this by making the sparsity pattern depend on the content. Instead of deciding in advance which positions to attend to, the model looks at the actual query and the actual keys and selects positions dynamically. The process has two stages. Stage 1. A lightweight indexer network runs across the full context. This is not the main attention mechanism. It's a small, cheap scoring function. For each query, the indexer computes a rough relevance score against every key in the sequence. Think of it as a fast pre-filter. It doesn't need to be perfectly accurate. It needs to be accurate enough to separate the positions that matter from the positions that don't. Stage 2. The model takes the indexer's scores, ranks them, and selects the top 2,048 tokens per head. Full attention, the expensive query key value computation with softmax and weighted sum runs only over those 2,048 selected positions. Everything else is dropped. Put numbers on that. At a 1 million token context, the full attention computation would require 1 trillion pairwise scores per head per layer. With DSA, it requires roughly 4 million the 2,048 selected positions scored against each other plus the current query. That's a reduction from 1 trillion to 4 million.